Hi, everyone, and welcome to this month's Rancher Online Meetup. We've got a great topic today. We've got a huge audience and some fantastic speakers. So hopefully we'll have a great time and be able to really answer a lot of questions you have about how you can secure your deployments. So just a quick round of introductions. Today on the phone, I've got myself and my co-founder Darren Shepard here from Rancher. I'm one of the other co-founders. We've been working on this and hosting this meetup now for about 2 years. So thank you so much to everyone who comes and attends and sends us ideas and volunteers to come and speak. We've got a great group of presenters today, including Bill Maxwell from Rancher. He's our director of DevOps. He's going to talk a little bit about just some best practices around securing Rancher. And then Fei Wong from New Vector is the CEO there. And then finally, we'll have a couple people from Black Duck. Mike Pittenger, who is the VP for Security Strategy, and Kayla Gervais, who is a field engineer, and will be demoing a lot of cool stuff on how to use Black Duck. So we've got a great group of presenters. We're going to cover a lot of stuff. Just a couple housekeeping items first. This is a meetup. It's not a webinar, and we talk about this every month, but just because of that, there's a couple things to consider. One, we don't set a time to be done. This session will go longer than an hour, I guarantee it. We've got a lot of content to cover, and so we're recording it. Everything will be available afterwards for review. You can watch it again. If you have to leave to go to a meeting, don't stress. You can come back later and see everything that we've recorded. We'll also post the slides. For those people who always ask that question, we will have the slides up on SlideShare and post those out, and when an email goes out afterwards, you'll have links to both. The big reason, though, this is kind of the difference between this and your typical company webinar type of thing is we're here to answer your questions. It's meant to be a two-directional conversation. The technology doesn't allow us to all see each other and talk really well, but what we can do is use the questions tab to fire in your questions. I will be moderating that, asking that to the speakers, responding where I can, but use the questions bar. It is fantastic. It works really well in GoToWebinar, and we can really use it to share information. If you do have a question that you want to ask out loud, let me know. I can probably unmute your line and you can fire away verbally if it's complex. The other big thing is we are here to demo. We're not here to just present slides. So this topic is pretty in depth. So we will present quite a few slides that kind of explain some of the concepts around security and some of the things you need to consider around securing your containers and your pipeline. However, we're going to be showing you everything. We're going to be showing you how this stuff actually gets done. And because of that, be patient. Sometimes things don't go as expected. These are live demos. We don't record videos, and if something's not quite going right, we try to have a backup plan. But be patient. If you've been on these before, you've experienced this before. The other thing is, we're a great group of people. Thousands of people are registered to attend every month, and auto sign up every month to be on the next month's webinar or meetup. So please introduce yourself. We're on Twitter. We use a handle called Rancher Meetup when we have these. It's a great place to post your thoughts, take a screenshot, and post up what you like or don't like about what the presenter's saying. Give a second opinion, mention some other approach that you think is very useful. But most importantly, introduce yourself. If you're sitting with a group of people and you're all having fun listening to this, take a picture, post it online, and introduce yourself. If you're having your lunch, post your lunch. We've had people post cars, they're driving in the car listening. So introduce yourself and get to know the rest of these people. Everyone on here is trying to do some cool stuff with Docker, with Kubernetes, with Rancher, and we want to expose it. And obviously everyone on here is interested about security, which just makes you a better person than if you aren't interested in about security. Okay, so here's our agenda. I'll just do a quick intro for those of you who don't know who Rancher is. I'll cover a couple things on that. Bill's going to dive right into best practices for securing your deployment. Faith's then going to go through some concepts around continuous security for containers. He'll then demo deploying New Vector on Rancher and blocking a dirty cow exploit. So we'll have a couple of elements to the demo. Mike then is going to go through and sort of discuss, what is Black Duck, how do people use it, why is it so awesome, and Kayla then will give us a demo of how to use Black Duck to inspect your containers and look for potential issues. So a lot to talk about, a lot of content. Hopefully it'll be really fun for everyone. For those of you who don't know Rancher and just came today to learn more about security, Rancher is a software company. We build open source projects. We have 3 of them that we talk a lot about. Rancher is our biggest project. It's a container management platform that's open source that runs all of your infrastructure, containers, and makes it really easy to deploy and manage your applications thereupon. Rancher OS is a tiny 50 meg distribution of Linux that is really popular for people who want to strip out everything but the basics for running their containers. And Longhorn is an open source project for doing microservices-based block storage that can be deployed wherever you run, whenever you run your containers. So those are some of the things we work on. I mentioned Rancher is kind of the primary focus. It has grown enormously since we started doing these meetups. There are now more than, I want to say, 10,000 organizations using Rancher. It's been downloaded, across agents. More than 60 million agents have been deployed and run out there on hosts. There's, hundreds and hundreds of terabytes of RAM up and running every day. Running containers on Rancher, and millions and millions of containers. So it's a very popular platform, and the whole point of it is to make it very easy to run your containers everywhere, run them on any infrastructure, and make it so that you can manage your applications. And what we do under the covers is basically pull resources from any cloud, VM, host, bare metal machine, pull those into environments, and allow you to then deploy a set of infrastructure secure services across those environments, as well as an orchestration layer. So you create an environment, it's a Kubernetes environment, or it's a cattle environment, or a Swarm environment, and those environments then are managed centrally. You have a central management plane that controls access and monitors those environments, makes sure they're stable and secure, upgrades them when they need to be upgraded, and you plug that into your CI flow, your registries, your monitoring tools, your logging tools, and start to get busy deploying containers. So Rancher is, as I said, it's really geared around making it as easy as possible to consume and deploy containers out there in the real world. So that's sort of who we are, and this is an area we spend a lot of our time working with very large companies that use Rancher in production, that are often government agencies and financial services companies and broadcasting companies and media companies and stuff, and so almost inevitably for most of these projects we spend a lot of time talking about security. So this is an area that is near and dear to our heart, and we've been just really impressed with the growth of the security ecosystem around containers. So we came up with the idea for doing this meetup. We really just wanted to bring together a couple companies, have them talk about what they're doing, and hopefully we'll run a couple of these over the next year where we introduce you to different security companies, what type of approaches they're taking to secure your container stack. So one of the things Bill's going to talk about is really the broader ecosystem and how what different layers you need to think of when you think of security. So Bill, you want to just start off? I'll sort of get you to your first slide.
All right, so we're going to just be talking kind of high level about security and Rancher and kind of some best practices, and just taking kind of the high level view, and then our demos will dive deeper into this. And so just kind of looking at it, we've got security, and it's really a layered approach. And so as you're getting ready to run into production, there's really a lot of things that you can do ahead of time before you actually deploy and get up and running. So all the way back to your build and your development lifecycle, to the part where you're packaging and shipping and getting everything ready, and then your deployment pieces, and then continually monitoring that in your production environment and giving those feedback loops. So everything from analyzing your code and scanning things and making sure that you're following best software development practices, and then when you package, being able to get visibility into what's actually being created and getting ready to run, and being able to verify that, and then your whole production runtime environment from the OS level, whether you're running your kernels are up to date, your security patches on your operating system, or maybe you're running one of the more pared down OSs that have extremely small attack vector, like Rancher OS or Core OS. But basically really making sure that you're you have a secure host to build and launch and run applications. And then as you kind of move up that stack, as you shrink the OS that's underlying, the more the containers you run on there, the more variability that you get. So you really need some visibility into what's actually being used there. But also just the configuration management, problems that we've had for a long time. How do we get the secrets to our applications? How do we deliver all of this? And so that all comes into play in running containers and environments. And then then the internet's a dangerous place, and how do you monitor against external threats? So there's, we're going to be looking at some of those protections later on as well. Next slide, please. And so, when you're running on like a Rancher environment, we kind of recommend, really buttoning down your network. One of our common best practices is to have an external load balancer of some sort that exposes a common set of ports to the Rancher load balancers, and then use layer 7 routing inside there to just get all of the traffic. Now this really works only with HTTP-based type services, but if your environment is predominantly REST-based microservices, this pattern works really well because you don't have to expose anything except for 443 or port 80 to your external services, to the outside world, and then everything communicates over the Rancher IPsec network. And then at the host level, you really have just the IPsec ports open between each of the nodes, and then the traffic back to the Rancher management server. And so this kind of really gives you a nice way to sort of really lock down the network. And then if you want to go even a step further, Rancher has, in cattle environments, has the network policy manager, which allows you to have a finer grain control over which containers can talk to which on the Rancher overlay network.
Hey, Bill, there were a couple questions that came in right there. First was from Lei Wang. He said, what about L4 load balancing for WebSocket?
So, I mean, WebSockets come over, I believe they just come over standard HTTP ports, and then I think they are like an upgrade connection, so that I believe they should just work over in a similar way, but I'd have to test that.
Another question was from Lori Kepford, and Lori asked, would I use an AWS Classic load balancer or application load balancer for this?
We've had customers use both. And really, you just kind of need a dumb load balancer, because the Rancher load balancer is actually what's doing the actual intelligent routing. You just need traffic to get to the Rancher load balancers, and so you could do that with either.
You're talking about the blue top of kind of the high end.
Yeah, that blue top level load balancer could be, we typically use ELB, but with proxy protocol enabled. But you could do ALB as well for that, or F5, or take your pick.
All right. Does Rancher support an L4 load balancer? That's the real question Lei Wang was asking, though, is do we support an L4 LB, or do we include one? I think maybe, do you want to talk about that?
So we ship with HA proxy, and so it's able to do TCP based and port based, but it's so it supports that, and so you can load balance. So you can load balance all sorts of traffic. Again, this model is more for doing buttoning down more like HTTP-based services. And this way you get a lot more port sharing. When you can't route based on source port, based on the host header, then things become, you have to manage ports a little bit differently.
Got it. There was one last question on the LB side. Welly, well, there's three last questions. So he asked, does Rancher load balancer support X forwarded for header? Sorry, X forwarded for header.
Yes.
Okay. And then there was another one here. Is it possible to use CPX here for L4, LB, and enabling web stocks? Treat it like HA proxy. No integrated support for Rancher, but can be managed like any service. So that I think that was more of a comment from Brian. Tanis was saying that. And then there was the last question. This was from Max. It says, can you provide more detailed information after this webinar about load balancer setups? Currently, we want to deploy our stack from our CI pipeline. The problem I face is that the port is blocked when the app is deployed once. So Max, we've covered sort of that a couple times, but I think it'd be a great topic for a blog or for some comments. So thanks for the suggestion. We'll definitely do this. All right, so why don't I jump forward to the next slide here and let you keep moving, Bill?
Sure. And so the next step is looking at things is automating your delivery pipeline. And so as containers, all the way back from developers committing code to your dev, test, and production environments, automate all the things. Because each one of these things has access controls and is sort of controlling who has access to actually run your applications in production. So yes, ensuring that you've got your source code repositories locked down, ensuring that you typically in your dev environment it's probably fine for your users to directly launch compose files into a Rancher environment. But as you move into test or QA environments and production particularly, it's better to probably have something like a Jenkins or a drone doing an automated deployment. The credentials are managed, and so those users can, the developers or the operators can have restricted access in the Rancher environment, so they don't actually need to be able to deploy to these environments directly. And so you can kind of have that level of control going in there. But even before you get to deployment, there's also analyzing your images before they go into these environments, and when do you scan them, and when do you verify that things are going to be secured and you're not releasing any vulnerabilities into your next environment. And so Black Duck will be talking about some of the the scanning capabilities that they've got, and talking a little bit more in depth about making sure that the images getting into your environments are safe and secure. Okay. Leveraging secrets. One of the things that Docker's made super simple is sort of getting up and running quickly, and so as one of those early patterns, getting secret information has typically been done through like environment variables or possibly flat files. But how do you get those files to those places? And so the orchestrators have all come along and got integrated secret solutions into the product, and starting to leverage those now. The time is now to start really adopting those. I think in 1.7 of Kubernetes, they've stepped that up, and the secrets are encrypted, and Swarm has also got their secrets encrypted, and Rancher's got a solution as well that's very similar. But getting those getting that confidential information to your container in a secure way, moving it through so that it's not easily intercepted is critical. Just using environment variables now, just moving through the orchestrator, they show up in the inspect, they show up in logs, and so there's a high likelihood that they'll release leak from the orchestration systems, and so these solutions sort of help mitigate all of that and get the confidential information. Or stepping it up even further, when it comes to secret information, looking at solutions like HashiCorp Vault, really takes it up a whole nother level, just with their ability to create secrets for you dynamically, rotate secrets, short TTLs. One of the things Rancher is going to be bringing back is some of the capability of integrating, basically being able to issue Vault cubbyhole tokens. So you'll be able to define policies and get tokens to talk to Vault, into your container so that you can directly interact with Vault. Next slide, or if there's any questions.
Yeah, there were a couple questions there, Bill. The first one was from Patrick. He was asking, do you know any tricks to get Rancher secrets to work with regular Docker containers that expect environment variables without creating your own container images for them?
Yeah. So recently we've got an entry point thing that we sort of use to help, called Meetup. It's one of our little side projects that we use for a lot of things. But if you launch Meetup as a sidekick container and then override the entry point of the original container, it will read all of the Rancher secrets directory and create the environment variable there. It's slightly better this way because the files are there, and then you create the environment variable. It emulates the behavior that Docker is doing in their standard library image, where you can underscore file an environment variable, and it'll inject the content. What that saves you is it doesn't show up in the Docker inspect. It's not in any of the logs or the compose that way. But that's certainly one way to do it. If you look at the Meetup README, it sort of shows under the example for exec when it's talking about write files. It shows how to override the entry point, and so you just would add an additional flag.
Yeah, if you try that and need help, just ping either Bill or I on Twitter or on the Rancher Slack, and we can probably help you there. Another question, how is your secret, this is from Roy, he said, how is the secret actually set up in Rancher? Are you using Rancher's local backend encryption, or are you using Vault? If you're using Vault, are you able to use Vault's API to manage keys, or still need to go through Rancher's UI? And there's another question that's kind of similar. Ben asked, with HashiCorp Vault, are there plans to continue to improve on the Rancher/secrets bridge? Is that the Vault continued work that you mentioned?
So the secrets bridge capability is, we're looking at pulling that into the integrated Rancher secrets, so you won't have to deploy it as a catalog entry anymore. And so we've got a design going on that, and we'll be working on that in the next few months. But basically, it's doing exactly what Secrets Bridge did. The other part, so for out of the box, Rancher has its own keys and encrypts data, and then stores that in the local database. You can configure it to use keys in Vault using the transit backend. And so once doing that, then the keys themselves are managed in Vault in that backend. And then there is some work being done at, instead of it storing the encrypted data that it gets back from transit in the Rancher database, storing that in a location inside a Vault. And then Rancher's database would just have a reference to where that is. And then it would still flow like this, but it would separate the at-rest location from the Rancher database.
Cool. Last question on this. Jay had asked what encryption algorithm we're using. Is it triple DES or AES 256, or what's actually being used?
It's AES GCM, which is the same one that Vault Transit uses. If you're using the local one, yeah. And then it does. That's for the at-rest storage, and then when it does the transmission, it generates a one-time AES key, RSA, and encrypts the payload, and then that key is encrypted, RSA encrypted with the public key of the host.
All right. Thanks for covering all that secret stuff. Lots of questions there.
Yeah. And then the thing to still remember is that the basics still apply, right? Like even though you've got containers and they bring a whole new set of problems, it's not an excuse to slack on the original or all the things that you've been doing forever. So patching your operating systems, making sure that the underlying OS is still safe and secure, doesn't have any known vulnerabilities, or at least they're mitigated, or that they wouldn't impact you. You don't have to go so far as to use a minimalist OS. However, they do bring a lot of benefits in the container world, just in sort of mitigating the need to what you need to actually manage for patching. Still using SE Linux and AppArmor where those apply for your applications. If you need those layers of security, they certainly work with Docker. They require a bit more effort, but if you need it, you do. Still restrict your host logins. Who can get on the host, and then make sure even more importantly, like you got to manage your access to the Docker daemon similar to the way you would manage sudo. Or the root password on any account. So still just people will be able to run on containers, and that's kind of enough. You don't necessarily need them there logging in. And then the orchestration layers now, Rancher and Kubernetes in particular have been, and Docker to some degree, they all support RBAC and tying into your authentication backends. So Rancher with its integrations for AD and GitHub, being able to leverage those, and then with the underlying orchestration. So out of the box in a Cal environment, you get 4 levels of access controls that you can apply to users in your environment or groups. And then taking that into Kubernetes in the latest releases, we've added support for RBAC. So now you can kind of leverage both Rancher and the access controls, and so really restricting users down to kind of the pieces of the system that they need, and with the capabilities that make sense for their roles in the organization.
Thanks, Bill. There was a couple questions that sort of came through that were on mostly on the OS side, and these are questions that I'd certainly open it up to Faye and Mike, anyone else that wants to talk, answer some of these, because they're kind of broader questions. But Ben asked, are there any recommendations for container OS patching? For example, periodically querying the containers for OS and application patches required. Is that something you want to address, Bill? And feel free, if anyone else wants to chirp up, just unmute your mic and mention something you think would be important here.
I'm sorry, I missed a part of that question.
Yeah, you said, are there any recommendations for container OS patching? For example, periodically querying the containers for OS and application patches that are required.
Yeah, I can jump in on that. This is Mike. So as you see when we get into our section of this, what we do is create what we call a bill of materials, just as you would have for any other device that you're manufacturing. So it would be a listing of all of the open source, in our case, open source components at both the application layer and at the OS layer. And then we track the threat space so that as new vulnerabilities are disclosed or as patches are available, we can provide alerts. And that can be done out of band. It can be done right within the environment to block the launching of a container if you so choose to. But it's important to remember that it's a good question, because this ongoing monitoring for new issues is critical in this environment.
Yeah, thanks. And we're going to definitely talk a lot more about that as we get into the Black Duck session. Thanks, Mike. That's great. The other question that came in was Corey. Corey said, would it be possible to provide docs or best practices for AppArmor, SE Linux, C groups configurations that would be compatible with Rancher? Great suggestion, Corey. That's an awesome topic. I don't think we've covered heavily in a blog or in the docs. So yeah, I would love to do that. We'll spend some time on that maybe in the next month or so. Great suggestion. There was another question that came in for Bill, and Bill, this one was from Li Wang. He said, is there any BRAC tool available in the catalog, and I'm not sure if he means RBAC tool, but is there any tool specifically available in the catalog? Do you want to just talk to that? Because obviously most of the time the integration is done at the orchestration and the management layer of Rancher.
Yeah, I mean we don't have anything, I don't think, in the catalog that supports it directly. The Rancher out of the box, you integrate it to it's integrated and can talk to a bunch of different authentication backends, and then the Rancher environments on their creation screens or editing screens, you can assign users and groups from those authentication backends, different roles within the environment. Currently, there's 4. They can have the administrator or owner, where they can change everything in an environment, including access, members, which can change everything except for access, restricted, which can deploy applications but can't change anything in the infrastructure, and read-only, as it sounds. In the newest release, Kubernetes, if you're running a Kubernetes environment, we support you can enable the RBAC controls and then use the Kubernetes YAML to get that.
All right, cool. There was, I think, I'm going to cut off the questions here. There are a lot of great questions for Bill. Thank you, everyone, for asking those. Bill, thanks for covering so much and getting through it so quickly. Next up is Faye. Faye, are you ready? I'm going to pass you the ball, and you should be ready to go.
Yes, please. Yeah.
There you are.
Can you see my screen?
Yes, I can.
Okay.
You're actually sharing. Good job.
Cool. Thanks, Bill and Shannon, and nice to meet everyone here. So I'm glad to talk a little bit about, from a security angle, we are what NeuVector think the problem is and what we're trying to solve, right? So a quick self-introduction. My name is Fei Huang. I'm a co-founder and the CEO of NeuVector. So the NeuVector is a Silicon Valley startup, and the team DNA or background is all about networking, security, virtualization. It's really the team DNA. So we really look at the containers security from a network security angle, and we're really targeting the production of the container security problems, as Bill mentioned earlier, right? So if you look the whole container security space, you're gonna build, ship, and run, right? There are multiple stages. You want to harden your OS, you want to do the digital sign, you want to do a lot of preparation, but when your container goes to the production, so what are the issues there? So I want to talk about this issue today from this specific angle. Feel free to raise any questions if you have. So let's, before we talk about the solution, so what are the changes, right? Compare the container to before, like the original legacy or traditional ways of running applications, server applications in a data center. So I think the big difference is the east-west traffic was explosion. So suddenly a monolithic application become hundreds of thousands of microservices. Then before the inter-process communication suddenly become the network communications, and you opened so many network interfaces internally, and those from the network security angle, it's a really a risky situation, right? So that's one. Also, because this microservice, this beautiful containerization trend, it's built based on a lot of tons of nice open sources. But also, it's a challenging that because open sources have so many, and the vulnerabilities are being found again and again. We all know like a Heartbleed, right? It's been there for so many years, then suddenly we find that there's a security issue there. Those are I think we cannot guarantee the code is 100% secure in most of the open sources, but we should lay out some enough protections, multiple layers of protections to provide best security around that. That's really what you want to do at the runtime to protect. Also, if you look at the recent, I think maybe a lot of people already heard the ransomware attack. There are a lot of network attacks still happening today. I think it's even increasing because more and more workload and applications are moving and migrated to the cloud, become public facing, become like a large scale cloud applications. Then actually, those port scanning ransomware attack like Samba-Cry, WannaCry, right? Those type of network attacks are gonna still happening a lot, and it actually hits the container heavily as well. So those are the network security issues we were seeing almost every day in the public cloud environment, especially, right? So then what's the issue of the traditional security model? Like some of the traditional firewalls is guarding the gateway of the data center. So in the container space, it is blind. It cannot see enough information, what's happening inside the data center, especially the east-west traffic. Because the containerization does provide another layer of virtualization on top of your virtual machines or your physical servers. That basically give you underneath it's going to be SDN or some type of network virtualization. So that makes the traditional way of your security tools like a firewall or agent-based solution, it cannot see enough east-west information. It doesn't have a good application context. And another big issue is the container was up and down, the scaling so fast. So the security cannot keep up. One example is we see a lot of customers running on public cloud, right? They inside their public cloud environment. It's just so hard to manage the security groups, right? How can you predefine and manually configure your security group for every of your microservices when it's dynamically scaling and changing all the time? So it's really hard to keep up, and also because of lack of visibility and cannot keep up. Also, the application context was lost, so it's a low accuracy, right? So all those issues are kind of like cause the difficulty for the traditional security tools to provide efficient protecting for production containers. So those are the things we believe you need a better security to protect containers. So what's from our angle of view, what it should be, right? So to do a container native security, we believe, especially for runtime production containers, you need a really good container native firewall. You need to do very good network visibilities, so you understand how your containers are talking to each other at runtime. Also, to gain deep application context, you need to have layer 7 inspection as a capability. Because without layer 7 inspection, so the microservices are just a piece of a puzzle. You don't have a good whole picture, and you don't understand, is that really your microservice should work in a runtime production environment. Another key point is you want to keep up with the cloud native apps. So especially when your application was scaling up, scaling down, when you update, migrate, or you adding new features on your containers, you want have the security solution follow up. You don't want the security behind the change, right? You don't want to see for example, I know some of the companies, they can release thousands times per day because of microservice. They can quickly push out microservices, then just release some new features on the public cloud. In that situation, you don't want the security team say, hold on, I need to review everything and define the policies that allow you to go online, go public, right? So those are the kind of like challenges. Also, your solutions should be able to handle, especially for the security firewall solutions. You want to have your when you change that, when you migrate that, the security gonna still follows, right? Then the third one is not like before, the security kind of like separate from the traditional way of manage. Like you are managing your applications, but the security people may managing the security agent or firewall in a different way. Today, it's all about efficiency, agility, and speed. So it's a CI/CD process. You would like to have your security solution fit into this CI/CD process, be part of it, right? Not I have to use another different management console, different management platform to manage security. That doesn't make sense at all. So all those key points is really for make the security work and efficient for the containerized environment. So then the question is how to make the container security keep up. So from new vector point of angle, we were thinking, okay, container are declarative, right? Container have a lot of metadata information like names, labels, dependencies, links, everything. The beauty is it's a standard interface. So those information should be leveraged to gain the deep security around that, right? Another one new vector was focused on we do behavior and machine learning technology around the container runtime activities, because only you can do machine learning and behavioral learning, you gain the deep knowledge on the application, communication and patterns. Then you can provide a strong whitelisting policy around that. And also, because it's based on the machine learning, it can automate it. That's a key point here, right? Only when the security can be automated, then you can make sure the security can scale and follow your container changes. So those are the kind of key technologies new vector built to make sure it can seamlessly fit into the process, fit into the platform, and fit into your scaling container microservice environment. So then if you look at the features, then at the deployment angle, right? So security solution has to be support greenfield and brownfield deployment both, because this is a microservice environment. You cannot ask people, hey, you have to deploy this security thing you can do that, but a lot of the situation is I want to have my production microservice running there, that I want to auditing that, do the live scanning, do the live protection on the containers. You're going to have to make a security a service, make it a plug and play, right, model. So new vector's solution itself was containers. We're containers. We are not agent. We don't embed anything into your container. We don't require any code changing, right? It's just a pure containers, container firewalls. And so you can deploy and use the new vector container in any platforms like a Rancher, Docker, Kubernetes. It just all smoothly fit in, because you just kind of like manage a different container side by side with your applications. That's really what the security of new vector can provide. Then once new vector container were deployed, right, we can do quick auditing on the whole environment at application level. For example, new vector will do the Docker bench CIS benchmark scanning. We will do Kubernetes CIS benchmark. Also, we will do quick vulnerability scannings. All those can be very valuable auditing reports for you to evaluate your Docker environment, not only the container itself, but also the host, also the platform you were running containers. Those are the basic features we have. And then at the runtime, we have multiple layers of protection. We believe to have a good protection around the containers, it's not a single level protection. It has to be multiple layers. For example, you need to have a good security at the network side in place, because think about for example, today's popular network attackings. It all start from a port scanning. So you want to prevent some attacking at the network side even before it reaches your containers. That's one type of attacks. You want to have a good efficient protection. So you want to have a good network layer segmentation isolation, right? And also inside the container, because for example, if some malicious code was embedded into one bad container, then it can cause damage from internal, right? So you also want to have another layer of protection, which is doing good detection and on the privilege escalation or breakouts inside of the container. This is another layer of protection you want to have, and then NeuVector also have that features, right? So the third layer of protection is really some network threats. For example, the 0-day, right? The DDoS attacks, the DNS attack. Those network attacks, it's really it can cause huge damage, right? So it came from network. It could come from internal or external. So you do need some application level threat protection around your containers. Doesn't matter it came from north-south traffic or east-west traffic, because once your load balancer or web server got a DDoS attack, it just stop the whole application. That's really where the risks are. So you need another layer of protection there to protecting your from the popular threats. Then the last layer is that when we see anything abnormal of the environment, you want to have the container security solution basically feed the data into your SIEM platforms. For example, you use Elk, Splunk, or whatever tools you are managing the security responses. You want to see those traffic there, and you can correlate those events and logs back to your gateway product or other security solutions together. So all the security solutions suddenly link together in your SIEM system. So you have a very good global picture of the whole thing, and you were able to take actions based on all levels, all granularity of the security reports. So those are the major
questions that have come in. Do you mind if we stop for just a second on this slide and dive into those?
Yes, please. Yeah.
Absolutely. So so one question came in from Dave. He just asked, is NeuVector an open source project? Is it a commercial project? What's the license on NeuVector?
Sure. NeuVector was a commercial project, and also we have a partial of the open sources there. For example, we do have a Kubernetes CIS benchmark as open source modules. And for the pricing, I want Glenn to help answer this question.
Oh yeah, we're a commercial product and licensed like typical enterprise software, so it's on a per Docker host basis.
Okay, great. And then Max asked a question. He said, by whitelisting, when you talked about whitelisting, what do you mean exactly? Do you mean being restrictive to define which container can connect to another container? Is that what you mean when you talk about whitelisting? Is it about network whitelisting? Can you just elaborate on the whitelisting comment you made earlier?
Yes, it's. I would say it is yes, and it's more than that. So it is, for example, the whitelisting going to be on my slide on the right corner. You will see a graph here, right? The whitelisting means we're going to define the automatic generate rules, like my load balancer can only talk to my Node.js containers on specific protocols. For example, that's part of the whitelisting. But I would say the solution is more than that. Networking is part of that. We also enforce inside of the Node.js containers, you can only have your normal processes running, for example, and it's a behavior of the container basically. Think about it, it's a whitelisting of the container behaviors. Yeah. Include networking. Yeah.
Got it. Okay, so it's container behaviors. Besides networking, though, what other areas is it whitelisting?
Like processes running inside the containers, like the privileges, a lot of angles. Yeah.
Got it. Okay, so you can't make changes to those without modifying a whitelist. Is that how it works?
Basically, machine learning gonna gain the patterns, the behavior of every container. Then once you lock it down, anything different from that, we will treat that as abnormal, and we will raise an alert or take some actions.
Okay. Pierre sort of has to follow up to this. He said, does the whitelisting occur through analyzing links in the Docker Compose or Kubernetes YAML files, or through some other way of doing this?
It is a combination. As I said, of course we look at the metadata of the YAML files of the container engines. We also look at the live traffic of the containers. So it's combination of networking and file system process, the metadata. It's correlation together. That's why the normal firewall, right, cannot go that deep. It's really application context related, correlation, machine learning stuff.
Okay. So Rob asked, he said, I may be jumping ahead into the weeds, so if you're going to cover this in a minute, you don't have to hit it here, but are you going to present a best practices for avoiding container processes that run at root?
Yes, I may not be able to demo today, but we do have a feature. We're monitoring all the process privileges inside the container. And if, for example, there's a malicious root escalation happen, we're definitely going to raise alarm, and you can take action around that. That's one of the feature, one of the protection layer I mentioned.
Got it. And that actually brings up a question that Bruce asked. He asked about the respond section. He said, is there an exporter for Prometheus in order to consolidate alerts or other sort of standard outs?
Yes, we do support syslog integration, for example, and also because the security solution itself, NeuVector are containers, so you can definitely use Prometheus to collect NeuVector logs as well. So all the logs can go to same tools or third party.
Great. And Darty asked, what kind of behavioral learning is NeuVector actually using here? Can you elaborate on the behavioral learning component?
We actually, it's very specific for security purpose. So we cherry pick what are the events and logs, information which is related to security, analysis. So we pick those information together. Now, of course, we do like a correlation and learning. And the key here is really understand how individual container should behave in your production environment. That's the angle how we get a machine learning adapted, and then based on that we generate the whitelisting as a baseline. Yeah, okay. I hope that yeah.
So Jay said, well, maybe just before we pass, Brian asked real quickly, do you use standard machine learning algorithms, and what are you using under the covers?
We don't use standard machine learning algorithm. We basically home built some algorithm to correlate the information, because these are very specific use cases. We cannot simply use standard machine learning algorithms.
Okay.
Yeah.
So then there was one more question. Jay said, does NeuVector sort of take the place? Is it something like a web application firewall?
I would say potentially we do see everything. We do see all the packets or network bytes flowing into your web servers, for example, and we do have capabilities to prevent the threats to your web servers. So you can think of us as a deep application security firewall there, and but I don't think we can work together with other WAF projects with no issues. I think it's really about how many layers of protection you want to have. You want to have some WAF in your gateway to, for example, to take care of 90% of the attacks, right? But there are going to be advanced attacks still go into your data center. We see this all the time. Then you need to have another layer of protection around your containers to deal with those advanced, 10%. So we can work together.
Okay. Now, Faye, maybe you're going to cover this in a second if you go through an architecture slide, but there's a number of sort of architectural questions. I'm just going to kind of hit them really quickly, and if you're going to cover this, maybe just jump to the next slide. But Sunny asked if NeuVector was actually doing full packet capture on each host, or is it deployed in some kind of proxy mode? Willie asked, how do you monitor traffic between the containers / pods? And Jerome said, are you deploying agents, or are you capturing the traffic at a network layer? So maybe you can just sort of touch on those topics. It looks like this is kind of where you're heading anyways.
Yes, exactly. So New Vector, as I mentioned, is unique and special. Is we are not agent based. There's no need to install anything. It's just pure containers, right? So the technology really behind it is we were able to see all the traffic between your application containers once we were there, and it's not a proxy, right? We don't do proxy because I think it's too heavy for the security purpose. Also, we want to make sure it's really lightweight and fast. So you can see this architecture global view. New Vector is going to deploy one enforcer container per Docker host. So we just need in the typical case, you just need one security container per Docker host. It sits side by side with other containers. Then we were able to, basically we have two modes: monitor and protect. In the monitor mode, we will see all the traffic, but we don't block anything. Think that as an evaluation of the environment, and give you the, doesn't hurt anything. It's non-intrusively look at, monitor all the activities. Of course, if you want to put us in the inline mode, which is a protect mode, New Vector will be able to block individual network sessions, and that's also, when you want to put the protection on for the strict security environment. We don't. So what's the other questions? So we do have a manager module, which is a management console. It's also a container. So management console is just a viewer. Think that's kind of like a browser or viewer. When you need that, you just run a container anywhere. As far as it can talk to our central controller, you can access the UI. You can define the policies if you want, or you can configure the system stuff. So the release security containers are the controllers and the enforcers, and we support HA as well, by the way, because this is a production environment. So New Vector containers itself gonna form a HA cluster. Any of the nodes goes down, any of the nodes lost protection, we will able to raise alarm, and also we're able to identify that right away. And you can even take a follow-up action based on that, critical events.
Faye, thanks for diving into the architecture in more detail. I think Daniel asked a really good question. He said, just when you start adding these things to lots of hosts, there's always a bit of a concern about how to how to account for that when you're sizing your resources. So what kind of extra resources are needed for these containers on the host? What kind of processing are you doing locally? How should they sort of take this into consideration? What are best practices?
Sure. So New Vector by nature was designed as a lightweight container, right? Our enforcer only 70 megabytes. It's super lightweight. So we try to make the security a really lightweight container-based solution, and doing a lot of automation there. And for the resource sides, we also leverage the platform capabilities. For example, you can use Rancher or Docker, whatever. You can give a resource limit there. That's the beauty of the containers. So for example, if you think you can give the enforcer 1 gig of memory, right? 1 CPU core, that's kind of upper limit. You can control that. So we tested our solution on a lot of enterprise customers, and so far we didn't see any big impacts on the environment, because it is really designed as a distributed lightweight container solution. In the extreme cases, right, you can, as I said, you can always limit the resources for the security container as well. So that's really the benefit brought by the container platforms.
A couple other questions. Brian asked if we could go back to the machine learning, and he just said, so sorry to go back to this topic, but not necessarily the slide, but just the topic. Sure. Does it is New Vector doing real machine learning, or does it involve scripts? Like, what's actually happening here?
It is. I said it is kind of. It's not It's not AI yet. I understand, but the AI I think is still too far for us. Maybe that's the future, but for our specific use cases, it's very clean, very specific. Right, security, the containers based on the behaviors. So we really, as I mentioned, we learn We collect all the information we can collect, then we learn the behavior patterns from that. It is not it's not the common machine learning algorithms we need to adopt, and it's really something special designed for security purpose.
Okay.
Yeah, I think it's a big topic. If he's really interested, I'm happy to drill into details offline maybe.
Okay. Then Lei Wang asked, in some cases or environments, SSL or TLS is enforced. Would new vector still work?
Yeah. So the new vector was sits at the application level, which means we were above the networking, container networking. So we can smoothly fit into any SDN networks. For example, any plugins include rancher networking. It just underneath of new vector. We don't touch any IP table stuff, so there's no conflicts at all. So then we were able to work together with any like a Docker encryption underneath. It just transparent to the new vector solution.
So Sunny then asked, do you decrypt SSL and TLS?
A new vector solution itself, right? Our enforcers, controllers, yes, we use encryption channels ourselves, and
no. Do we decrypt between containers?
Oh no, we don't do decryption. As I said, the level we will sit the traffic flow into the application container, so we don't need to decrypt anything. That's why also we make it super fast.
Yeah, if the encryption happens under us, like if you're using Docker Swarm encryption, then we'll see it in the clear, so there's no need for us to decrypt it.
Yeah.
But for example, if you're using like an Nginx N+ plugin to encrypt directly between containers, then we can learn that behavior, but we're not going to be able to look into the actual
content
encrypted
right.
packets.
So we're going to help you enforce. For example, we do help some customers enforce the N+ protocols, which means, for example, you have a container, it should use N+, but somehow malicious codes is not using N+ protocol. We're going to help you enforce that. So that's another use case we were seeing.
Last question, Francisco was asking, just maybe for again on this architecture topic, how are you able to block the traffic between two containers without installing any agent into them?
Yeah, that's the one of the IPs new vector have, and I would say it's a secret source, and we like to discuss this offline. Yeah, with you individually. Yeah.
Okay. All right, so there you got it. Okay, go ahead, Faye, keep going.
Sure. So now I want to quickly talk a little bit some real use cases we were seeing. I think it's interesting because we were looking at all kinds of security attacks almost every day. I think it's interesting to share with the people, and so you get a better understanding why we think you need a network security for containers there. So this is a ransomware port scanning use cases. We were seeing a lot of port scanning happened, especially in the public cloud. You can't believe that you have all kinds of gateway security solutions already there, but we still see a lot of application level advanced attacks reached to the containers, like load balancers in this case, right? Load balancers. And it's doing the typical port scanning, but it's not a layer 4, layer 3 port scanning. It's really the layer 7 port scanning. And again, the information back. And what the attackers going to do is, based on the information collected, they're going to go find the CVEs, vulnerabilities in that environment. Then they can issue an attack, real attack, go all the way into your container. Once it gets into the first container as a stepping stone, it can spread out to the whole internal, application network. That's a lot of cases we were seeing. For example, the MongoDB Elasticsearch. You all know it's like a top 10 containerized applications. The MongoDB was attacked, after the attacker was getting into the container. It can steal the data out. It can encrypt your database tables, then asking for the money. We do know there are some real hospitals lose a lot of tons of money because of that. So it is a real, ransomware attack happened around containers. Doesn't matter you are using a container of MongoDB or, a VM-based MongoDB. It just, this type of attacks are happening, once in a while. You will see a lot of that. Because we were seeing all the north, south, east, west traffic, so we can report all those attempts, at a daily basis almost. That's one I think interesting use cases I want to talk about. So the next one is, I think a lot of people heard about the dirty call last year. It's very, very famous. So I want to quickly talk about, okay, what does the dirty call normally happen step by step? The first step normally it's when you're running like Ubuntu 14 point something versions, right? Not the latest version, they fixed that in the version 16. You will have a dirty call CVE there most probably, right? So when you use Black Duck do a scanning or use a new vector do a scanning, you will be able to find that. But for the production environment, if your VMs already have those, version of Linux kernel running, then you're under risk. So the attackers normally do is, as I mentioned, they're gonna do a port scanning first, then they're gonna figure out what's the kernel version of your, the version of your Linux system. Then if it's like a dirty call, enabled, they're gonna do is they're gonna basically inject the code into a CVE. They can basically through the network, they can inject the code into that container. Then they try to run this container run this malicious code inside the container, which gonna try to gain the root access. So that's really the dirty call vulnerability is. Once it's run the dirty call inside the container, it will become a root user of that container. Once that against the root escalation, right? Against the root privilege, it normally gonna create a remote shell back to the internet somewhere in the hacker's place. Then once they have the shell created, it basically can it own this container, it own the root. It can use this one. It can either scan the other internal containers, or it can just directly cause damages of your application and your environment. So this is a typical a dirty call kill chain. We call kill chain in the security space. Then from the runtime security angle, how we can protect that from new vector, multiple layer protections. First, we can do a quick live scanning and auditing on your environment, so we can report this one has the dirty call issues there. You can take actions automatically based on the scan results, for example. And then let's see if we don't want to shut down all my runtime environment to patch the system, right? So the new vector, the beauty is we were guarding the network at the first place. So we see the port scanning right away. We see those ransomware port scanning, dirty call, injecting phase right away. So we were able to block that because that's abnormal behavior of that container, right? You should not see those type of network traffic flowing into your container. That's why we really, new vector can do a layer 7 inspection. That's why it's important. If you only do layer 3, layer 4, you can't see that layer of attacks, right? So that's the second layer of protection. Then when let's say when it's a bad container, it's already running there. So when the process is doing root escalation to new vector, it's also a malicious behavior. That's not right. So we will report that right away, and we will be able to block that if you define some automated actions. So that's the third one. You can see we protect both networking, also inside the containers, right? Then the last.
Hey, I know we're running kind of long on time. Do you think maybe, I know you're going to show a little bit of something, as maybe we could talk this through as you're showing it instead of on the slide, and walk through a little bit of a demo.
Sure. The last one I want to talk is really a breakout stage. That's also I'm going to demo, right? So when you gain the control of a container, you try to talk outside world, like create a remote shell. this is abnormal behavior of the container, we're going to block that. So you can see in the whole kill chain, we have multiple layers protection there, right? So now I'm going to quickly go to a live demo here. This I'll skip. It just show you how from the vector console how you're going to see the logs about the privilege escalation and the breakout. Okay, so let me switch to my rancher environment. So I have a small rancher set up here. It's let me refresh that. You can see I have 2 nodes, right? 2 nodes already here, and I got a couple of containers running already. So right now it's a clean. I think this is a clean production environment. Nothing there other than some application containers. So I will show you how quickly we can deploy a security new vector solution on top of that. So to do that, we can just go to the catalog. So rancher does make this super easy to use, and your vector was already part of the catalog. You can see the new vector solution here. And what I need to do is I need to labeling one of the host. I'll copy that. So basically, this is to define where our management console will be installed, right? So I will pick this node to label that. Add a label. Save. So that's it. So now my preparation is done. I just need to go to do a one-click installation. Let's go to catalog, then search new vector. Then deploy, launch. Then you will see in about seconds, the new vector solution going to be automatically deployed on all your rancher nodes. It's already active. If we switch back, take a look, you will see new vector all-in-one containers was deployed on this host, right? And then you can see the enforcer container is on another host. Now I just need to go to the console of new vector. It's here. Refresh. This is our management console. Yeah. So let me log in. So this is really a fresh installation. So you're going to see a URL here. Let me shrink this a little bit. So you can see right after log into the console, we already detected how many active containers there, how many services there, how many nodes there, right? And if you look at this one, network graph. So we automatically generate the application graph. Those are the live traffic graph. So basically it tells you, okay, how your application containers are working normally. So this is a normal environment. Now I'm happy with this one. I want to do some protections, right? So it's very simple, just one click. See, I want to make this a monitor. So I want to monitor the security on those containers. You don't need to go through like a one service after service. What you can let me change to monitor. What you can do is you can do the whole thing at just one click. For demo, I just click 3 times. In the real environment, you could either just switch everything to the monitor protect mode. So now I'm in the protecting mode already. I'm trying to simulate a breakout. So I'm already logged into one of the hosts. Let's see if I do a Docker PS. Docker PS. You will see I got several Node.js containers here, right? I'm trying to simulate a breakout. Docker exec. Let's see node 1 cur http google.com. So you can see it talks to Google, right? Google web page appeared. Now if we go back, do a refresh. Okay, we see a red line. So this tells us we detected something abnormal. It's abnormal behavior. How could this Node.js container talking to the internet? You can, if you click that, you can even see we know do a DNS query first, figure out where's the Google, and then trying to do the HTTP query to the Google IP address, right? So this is we think about this as a real situation. the bad container gonna try to break out from the environment. It could either talk to external network or could either talk to internal somewhere. It doesn't matter to new vector because we know what's a normal pattern here, and we know this is something suspicious. So what if I want to block that? To do that, it's also super easy. Let me put the system into the protect mode. So now, which means we're going to be an inline firewall for the containers. Let me do the same case here. It's blocked right away. So because we know this is a malicious behavior, and we are in inline mode, so it's a firewall. We block this this connection. So if I go back, do a refresh, you will realize a small X in the middle. So we successfully blocked those attempts. So I'm just showing one simple like a breakout use cases. In some real attacks, you can see there's a multiple positions, multiple layers. We're going to provide a similar protection on the behavior of the containers. Yeah, of course, all the the violations, the logs, we're going to able to give this to your SIEM system or Splunk, Elk, whatever your management console there, so you can do the deeper analysis based on the source, destination, etc. So this is my quick demo. Any questions, please? Hello? Have we lost?
Sorry, I was muted, talking to myself.
Okay.
Yeah, there was one question. There were a couple questions that came in. One was from Sunny. He says, "Do you support detection of pure layer 7 attacks like XXS and SQLI?"
Yeah, we will detect those. Yeah.
Okay. Another question from Max was, "Is this version that's in the catalog a free version? Is it limited in some way? What's the license on the version of the catalog that you click through?"
Oh, from the catalog, you can get the containers. Then we give you a trial version, good for 30 days. Something you need to contact new vector to get started. I think we need to add your
trial license.
Yeah, trial license. Yeah.
Great. There was a question from Jerome just saying, how are you dealing with the IPsec encrypted traffic between nodes? I think you talked about that before, but maybe you could just kind of touch on it again.
Yeah, if you've got IPsec encryption between nodes, then we're above that. We're actually sitting above that, kind of at the container level where your applications are. So we would see the unencrypted traffic.
Okay. Then Darty asked, how many false positives do you see?
It's a whitelisting, so it's I would say there's no false positives because if you see this is the right behavior of the container, it is what it is, right? And of course, if let's say our machine learning didn't learn 100%, that's totally fine. As I showed you, you can put the system in the monitor only mode, then you will see the red line happen. You can always keep fine tuning the policy at the runtime. So that you don't need to do anything manually and anything at the front, right? You can always keep fine-tuning it. So there's a whitelisting solution. There's no really false positive or false negative related. It's not signature-based at all.
Okay. Were you going to cover anything else in the demo? I know we're kind of gone long now. Did you want to cover one more example?
Yeah, I think that's pretty much my quick demo is, and
okay.
Yeah, thanks everyone. Yeah.
No, that was great. There was a few more questions, Faye, before we wrap up. So I was going to hold them if you had a couple more questions, things. But Max asked if you can allow or block specific calls to the outside. Thinking of a website downloading requiring files from a CDN. So can you sort of manage what's whitelisted, what's blacklisted on the external calls?
Yes, we do. So the specific feature new vector have is as I said, we were able to see. It doesn't matter it's internal, external traffic. We were able to control that. So for that case, you can manually define a policy in our system, so we can limit the access to some specific sites. We can definitely do that.
Yeah. Jerome asked, how do you load a whitelist pattern and apply that on a newly deployed set of containers?
So our policies was I didn't get time to show much details, but it's, as I said, it's really the behavior patterns. That's why when your containers are scaled, when you are changing your cluster size, it doesn't matter to us because we discover, we learn, we auto apply the same policy for the same cluster of containers.
Yeah, just to add to that, if you've got something already in production and it's locked down, and you're deploying a new application stack with different behavior, you can put that application stack into the behavioral learning mode before you lock it down.
Right.
If you're changing the behavior of an existing application, you can just take that particular container stack or image and put those containers into a learning mode. Or if you want to integrate it with your CI/CD pipeline, you can use the REST API to add policy rules directly into the whitelist.
Awesome. Okay, so there was a last question. Michael said, do you have to have a host dedicated to the all-in-one container, or can an enforcer also run on that same host?
All-in-one, today the all-in-one have an enforcer built in, so you cannot run multiple enforcers together. But the all-in-one is also one container. So as far as you have enough resources, you can put all-in-one container anywhere in the network.
Okay. There were a few questions about like competition. So how do you differ from things like Twistlock and StackRox and Aqua? Guys, I hate to do. We're kind of running low on time, so I'm going to skip the sort of how do we compare to things. There's definitely lots of different people that are doing cool stuff around container security. As I mentioned, we'll probably have different ones come on and talk. But feel free to shoot those questions out into Twitter, #Rancher Meetup, and I'm sure people will give you thoughts on what they're using, what they like. Yeah, well, thank you for that, Faye. It was really great. Glenn, thanks for chirping in there. Now I want to turn things over to Mike. Mike, you unmuted and ready to go?
I am.
All right, fire up that thing. You should be able to share your screen now.
Okay. Well, I'm trying. Let's see. Oh, here we go. There we go. Is that visible?
All right, we're seeing it. Yep.
Okay, terrific. So I'm going to go through a little bit about who we are very briefly for those of you who are not familiar with us.
Mike, do you want to put it into the slideshow mode, though? It's still showing kind of all the slides.
Oh, huh. It's showing slideshow mode in mine.
Maybe you're on the other screen.
I've only got one screen going here. Let's see.
Oh.
Is that still showing all the slides?
Well, it's showing kind of the where you can see the left-hand view. It's not the end of the world if you want to go through them. I can still see them fine, but it's not full screen.
Yeah. Okay, let me just do it this way then. So Black Duck's been around since 2002. We've got about 350 employees around the world, over 2,000 customers. And basically what we're doing is helping companies understand what open source they're using and use it more effectively. And we do this by scanning build input or build output. So typically we're going to be integrated during the SDLC, we'll be integrated into the build process. And we will scan the code base, takes a couple of minutes to do. And the output of that scan is what we refer to as a bill of materials, but what you might think of as a laundry list of all of the open source components that are being used in that particular project or application, down to the version level. Once we have that, we can tell you anything you want to know about it. We've been doing this for about 15 years. We track over 2 million unique open source projects and every version of those. But what will surface automatically is security risk. Have there been vulnerabilities publicly disclosed in the versions of those components that you're using? We'll talk about license risk. Is that open source project license compatible with the deployment model that you've told us you're using? For example, are you using a GPL licensed component in an application that you're going to be distributing? And the third metric we refer to as operational risk, and it's really a metric or a measurement of how well supported that open source project is. How many community members are there? Is activity going up and down? How many commits have there been in the last year? Are there newer versions available, and so on? We do this throughout the SDLC, and the goal here is to make sure that when you ship your product or release your product, it's free from vulnerabilities, and that foundation of the product is made up of open source. Because security in these projects and software in general is pretty ephemeral, we then continue to monitor the threat space so that as new vulnerabilities are disclosed, we can alert our customers to those, whether that's in the application layer or in the container layer. And if you think back, when we got started in 2002, to be honest, a lot of people used our technology in order to find open source so they could get rid of it. There were some pretty squirrely licenses. People were concerned about having open source. It was viewed as kind of rogue software. And today, it's obviously taking over the software development world for good reasons. It's lowering our development costs. It's accelerating time to market. It's being used in the Department of Defense. Literally every industry across the world is using open source. We did an audit of some code base, commercial code base, last month, earlier this summer. It was 98% open source. So we're seeing it adopted more and more, and obviously in the container world, it's taking this by storm as well, by virtue of Docker and containers and so on. And this is good overall, right? Because it's providing us a lot of unique opportunities to organizations. It's changing how we deploy applications. It's allowing us to do that more quickly and easily. But it also has some challenges, right? There are a lot more individuals who are going to be involved in the creation of a container than would normally touch a traditional system. And interestingly, a problem in a single container can manifest itself as into hundreds or thousands of problems as those containers are propagated. And we saw this. Many of you may have seen this study from Banyan Ops about 2 years ago. We did a similar one about a year and a half ago. But they looked at Docker Hub and found that over a third of the official images on Docker Hub had vulnerabilities. We looked at it about 18 months ago, and it was well over half of the approved images or the approved containers, official containers on Docker Hub had vulnerabilities. Now, it was often the same vulnerability, as you can see here too. It was somebody had a base Linux image that had an old version of OpenSSL that had Heartbleed or Shellshock and some Heartbleed in it. And because of the way containers are often managed, where you'll just strip off the application layer, put a new application layer on top of it, if you're not keeping track of what's in that base layer, you're going to you risk propagating a vulnerability, and these vulnerabilities increase over time. So put a little more kind of some fun facts to know and tell around this. So part of our business is licensing our software. Part of our business is also doing on-demand audits during software acquisition. So if I'm going to buy your software company, I may bring in Black Duck to make sure I have freedom to operate. So we'll go in and do a one-time audit of the code base for IP issues around licenses, for security issues, and so on. Last year we did over 1,000 of those, and in this study you can download it from our website. But the kind of the high-end, high level facts of this: 96% of the applications that we looked at had open source, and on average that was 147 unique open source components. If that seems like a lot to you, it also seemed like a lot to the code owners. When we do one of these, we'll typically ask for a list of the open source components they're using in advance, and 75% of the time the customer doesn't have them. But in those cases where they do, what they're aware of is about 45% of what they're actually using. So they might think that they're using 60 or 70 components when actually they're using almost 150. This is a little bit of a lagging indicator because again, we're going in there doing an M&A process, and if I'm going to buy your software company's probably been around for longer than a year or so. So these are larger companies. The code bases might be 5 to 10 years old. 5 years ago when we did this, about 3% of the code bases were comprised of 50% or more open source. Today it's 22% of the code bases are more than 50% open source. Now, of course, it comes with risks. The benefits always come with risks. 96% of the applications used open source. In 2/3 of those cases, there were vulnerabilities, known vulnerabilities in the open source components in those applications. On average, 27 of those. So again, 2/3 of the applications had vulnerabilities in the open source that have been publicly disclosed. In this case, we only used the National Vulnerability Database. So we weren't, going and finding it, going on the dark web to find vulnerabilities against which to measure this. These are things that anybody had access to for free. Most surprising to me was the age of these. The average vulnerability had been disclosed more than 4 years before our audit of that code base. So these are vulnerabilities that were either added directly into the code base when the code was first built, or they were disclosed over the previous several years. But the code owners, for some reason, either they didn't know they were using that component, so they didn't check for vulnerabilities in the component, or they simply, maybe they knew they were using it and they didn't, just didn't bother to check for vulnerabilities. And this is a big problem because open source isn't any less secure, or frankly any more secure than commercial software, but it does have some characteristics that make it particularly attractive to an attacker. The attackers have access to the source code, for one. We publish the vulnerabilities in the National Vulnerability Database, often with an exploit or a proof of concept. So they have the information about it. They know it's a target-rich environment because open source is so broadly used. If there's an issue with WordPress or OpenSSL or a Linux distro, there are a lot of targets available. The biggest thing, though, is that there's not the support model for open source is really upside down from what it would be with commercial software. Other than things like Red Hat and so on, if you were, let's say we're building an application, we want to take some numbers out of a database and make pie charts or something, call that functionality, call it a rendering engine. If we use a commercial rendering engine, we license that, we have an SLA with that vendor, so they're obligated to answer our questions. If there's an update to that component, they're going to push that to us. If there's a security issue, they're going to notify us and push us a patch. Open source is the exact opposite. With open source, we've elected to use this open source component, this open source rendering engine, and now it's up to us to monitor that. And if there's an update, nobody's going to tell us about it. If there's a security issue, we have to be aware of that and make an election as to whether or not we're going to pull that update into our code base. So we've got a push and a pull model. Now, one of the things we get asked a lot is, why aren't we finding these things in testing? A lot of companies are doing security testing. And you have to understand that the testing is good. It's helped our security a lot, but it's not a silver bullet. So we have things like static analysis, where we're creating an intermediate representation. We're mapping out the control flow and the data flow, creating this rich model of the application that we can then query. So, for instance, we can go and look for instances of a string copy and traverse the model and see, in that example, whether it's possible for the source buffer to be larger than the destination buffer, and if so, you've got a buffer overflow. Then we have dynamic analysis, where it's going to be very much later in the SDLC. You need a staging environment, you need a completed application, you probably need a test database behind it. And in those cases, we're going in and we're looking for inputs and perhaps fuzzing inputs to those. So we'll be looking for username and password field or some other input field, and throwing 1,000 zeros or 1,000 ones at it and trying to basically break the application. The graphic here on the right-hand side of the screen is from a study we did in the early days at Veracode. And at the time, there were about 600 CWEs, common weakness enumerators. And this is what NIST defines as a weakness in the software that could result in a security issue. And the universe at that time was 600. And we went through them one by one and said, for CWE1, is it technically, feasibly possible, theoretically possible, for that to be identified through static analysis, through dynamic analysis, or through by a smart human? So the black circle represents all possible CWEs, and you can see the Venn diagram there. And I don't remember the exact numbers, but it was something like the 600, maybe 300, 350. You could theoretically find with static analysis, and a similar overlapping number with dynamic analysis. And that overlapping area is common things like SQL injection, cross-site scripting, buffer overflow, and so on. But you can see there's a lot of things that you're not going to find with just static or with just dynamic or with a combination of those. And even within those tool sets, there are going to be differences. So if you think about that overlapping area being cross-site scripting, SQL injection, and buffer overflow. What was Heartbleed? Heartbleed was a buffer overflow. How many tens or hundreds of thousands of times must applications with a vulnerable version of OpenSSL have been tested during the 2 or 3 year period that Heartbleed vulnerability was present in the code base? And still it was never found, not through automated testing, not through pen testing. So it's good to use these things, but use them understanding what they're possible to do. What they're very poor at is finding vulnerabilities in open source. If you look at the National Vulnerability Database, of the 80,000 or so vulnerabilities, now I didn't look for each one individually. I didn't look for the reference on each of those 80,000, but I made an assumption that if I, as a tool vendor, if my tool found a vulnerability in the open source in the wild, I'd take credit for it. So I searched for all of the vendor names and product names and IBM and AppScan and Fortify, HP, Checkmarx, Sparrowcode, and so on. And of the 80,000 or so, 63 of the vulnerabilities, the CVEs, referenced the tool vendor. 50 of those were for vulnerabilities in the tools themselves, and 13 said something along the lines of could be found by a properly configured fuzzer. So they don't have a very good track record for finding these. So by all means, use static analysis, use dynamic analysis. We do on our code base, but understand that it's not going to be effective at finding the issues that are present in open source, and we're seeing 2,000 or 3,000 of those a year. So where do we fit in this whole mixture? Obviously we're used primarily in the SDLC, in the development process, so we can help you build policies around what open source you would use in each tier of applications, enforce those policies from the first build through deployment, and then do continuous monitoring for new vulnerabilities that affect your existing code base and provide alerts on those. In the container world, we can scan containers not just at the application layer, however, all the way down to the Linux stack. So you can also set policies around what is acceptable for deployment within the container environment, and we can enforce those policies. What we're not doing is looking at any of the network traffic, any of the application isolation and privileges and so on. All of that is being handled by NuVector. So it's a very complementary solution from that standpoint. We do have a container security scanner available. You can see the URL there. If you go to our website, you'll find more about it. If you have questions that we don't get answered during this time, you can see my email address and my Twitter handle there. To keep things moving here, I'm going to turn over to my colleague, Kayla, to walk you through a demo of this and obviously answer any questions you have as we go along. Turn that back over to Kayla.
Okay, Kayla, you're the presenter now. Feel free to share your screen.
All right. Are you seeing my screen right now?
We are, yes.
Okay, perfect. So I'm just going to go through one quick PowerPoint slide just to touch on the architecture of the solution, and then I'll jump right into the demo. So with the hub solution itself, it's really comprised of 3 separate components, which you're seeing on the PowerPoint slide here. So the first piece of the hub is the hub scan client, and this is the piece of the hub that would obviously be responsible for scanning your code. And just speaking to kind of Docker containers and Docker images, if you wanted to scan those with the hub, we do a deep container inspection, and that would cover both the operating system as well as any of the application layers. So once that scanner is actually kicked off, what it does is it runs through that container or code base and generates these unique IDs or hash values, which are based on a couple different factors. So we're looking at the file names, the file sizes, where those files live within your directory structure, as well as any declared dependencies and package management files, and then specifically with containers, looking at the standard Linux package managers as well for all the declared open source dependencies in there. So once all of that information is captured, it's then sent over to the Hub web application, where it gets encrypted and sent over HTTPS to the Black Duck knowledge base. And then once it gets to the knowledge base, all of the unique IDs that we found through the scanning process are compared with the unique IDs that we have in our knowledge base. And then for any matches, all of that open source metadata is sent back to the Hub web application and displayed for you in what we call the bill of materials. All right, so just jumping over to the second piece of the Hub, or the Hub web application. So once you're logged into the Hub, there's really a couple different ways that you can review your results, either from a high level, using these tabs up here, or taking a deep dive into a specific project that you scanned, which would be listed down here. And then at Black Duck, we really allow you to define the project however you're currently doing so within your within your organization. So in some cases, it may just be one project equals one application, or maybe even one Docker container. And then the Hub itself will calculate 3 different risk metrics for you. So the first one is the security risk. That's looking at the number of known vulnerabilities and their severity. The second one is the license risk. So that's looking at the types of licenses you're using bumped up against the distribution model you have set for that project. So whether it's external, SaaS, or internal. And then the operational risk is really looking at the overall health of that open source component you're using. So how old it is, how many newer versions are available, and then what the commit and contributor activity looks like over the last 12 months. And then the second way to really review your results from a high level in the Hub is through this Components tab. And what this will do is provide you an inventory list of all of the open source components you're using throughout your whole code base, encompassing all the projects that you've scanned into the Hub. And then as you can see here, you can sort by any of these columns or even filter down on a subset of components listed in the charts on the left. And then the third tab here is the Security tab. So this will, again, from a high level, show you all of the security vulnerabilities acting on all of the components that you're using throughout your code base. You'll also notice on the left-hand side, we'll have a chart of where those vulnerabilities stand in terms of statuses. So with each individual vulnerability that's associated to a project, you have the ability to set different statuses on where you are on the remediation path. So this just gives you a quick and easy way to see from a high level where each of those vulnerabilities stand and how many more you may have to perform to remediate them. And then the last tab over here will just give you a quick high-level executive dashboard of your project health. So looking at top policy violations, top project and component security risk, and then just some overall statistics on what you scanned into the system this week, and then overall. So let's jump back to this project tab for a second, and let's just pretend here that we've gone through, we've scanned one of our Docker containers into the Hub. And this is really how you'd go about reviewing those results. So as soon as that project is scanned in here, you'll see it populated on this list. And for this example, I'm just going to use the WebGoat container, which most people should be familiar with. It has quite a bit of known security vulnerabilities associated with it. So I thought this would be a good one to show here. So once you're coming into the version of that container that you've scanned, this is where you'll be presented with that bill of materials, or the list of all of the open source components that Black Duck found throughout that scanning process. So looking at the information that you'll see on the bill of materials, you'll see the open source component name, the version of the open source component that you're using. We'll also be able to show you using this source column exactly where we match that component to within your directory structure. So if we just take this example here, you'll see that this component matched to this jar file over here. And then you can also see that we're looking at each of the individual layers. And this can come into play if there is any security risk, associated with this component, and you need to know, where it is. You can go in and remediate it. The Hub will provide you that information by just selecting the jar file here, and you'll be able to identify exactly which layer this component is a part of. You'll also be able to see the license associated with that open source component. And if it is dual license, you'll be able to actually select between the two different license types that are associated with that component. And then just looking at the operational risk over here. So like I had mentioned previously, it's really looking at a number of different factors. So if I just hover over the risk here, we'll actually see what those factors are. So really looking at and considering how old the component is, how many newer versions are available, and then if the commit and contribute activity is stable, increasing, what that really looks like overall. And then lastly, maybe more importantly, the security risk associated with those components. So like I had done up here, if there's ever a subset of components that you want to filter in on and just focus on, you can use these charts up here to do so. So I'm just going to filter in on the components with high security risk here. And components that have high security risk, that really means in the hub that they have at least one or higher high severity vulnerability acting on them. And that's using the CVSS scoring system. So as you can see here, we're looking at the number of high vulnerabilities, medium, and then low. And again, if you do want to take a deep dive to understand what those vulnerabilities are, all you really need to do here is select that vulnerability number.
Kayla, one of the questions that came in, Lori just asked, does it show you how to remediate the issue? You want to just kind of maybe talk about that?
Yeah, that's a really great question, and that's actually right where I'm headed here. So once you're on the specific vulnerabilities that are impacting you, there's really a couple different ways that Black Duck will provide you remediation guidance. So the first way is using this update guidance section. So versions that you can upgrade to that'll get rid of that vulnerability, as well as what the most recent version available is that you can upgrade to remediate that vulnerability. Within each of the vulnerabilities themselves, we'll also provide you external URLs for different sites that will actually provide information on suggested remediation paths.
Fantastic. That's great. There was one other question real fast that I think you might be able to address quickly. Roland asked if Black Duck is available for local deployment or is it cloud only?
Yeah, another great question. So the nice thing about the hub is it can be deployed on your premises, and that is via Docker container, or you can deploy it via a SaaS model where we would host the web application and you would just have the scan client on your premises.
We didn't talk about this at the beginning, but it'd be worth, maybe Mike, you can jump in here too. What's the license model like for Black Duck? Is this commercial software only? Is there an open source version? You mentioned they're from free tools, but just to be clear, most of this is all commercial software, correct?
Yeah, that's correct. We do have a number of open source integrations that we provide, and we also have a website called openhub.net that is a home to tens of thousands of open source projects that you can go and find information on things like code complexity, functionality, number of contributors, number of commits per year, that type of thing. So as you're researching which open source project you might want to use, it could be a valuable tool for you.
What's the way you license the software? Is it based on the number of users, or the number of hosts, or the number of scans, or what's the general model for maybe smaller, larger companies? How should they sort of think about this in terms of cost?
Yeah, think about it in terms of capacity. So the amount of code you have under management. So if you wanted to, if you have an application, you can scan that multiple times, and in some of these, Kayla, if you went to one of the projects that had multiple scans, you would be able to see how many times and how the profile of the application had changed over time, but that doesn't increment the amount of code under management. It would really be the number of projects. So if you had 5 projects that were a gig each, should be 5 gigabytes, and irrespective of how many times you scanned it or how many versions you were keeping in there.
Awesome. So there's no penalty for being diligent and scanning frequently, and you baking this in to every step of your process. It's just more about how much code you're under managing.
That's correct, and you can swap out projects, of course. You could, if you had those 5 1 gigabyte projects, and you could remove one of them and add another one. The downside of that is with continuous monitoring. So if you think about what happened with Heartbleed a few years ago, and everybody's running around with their hair on fire and pointing Nessus at everything because they didn't know, everybody knew they were using OpenSSL, but they didn't know where. With this, you can just type in a component name. So when our customers, when this happened, they typed in OpenSSL, and it immediately showed them every version of OpenSSL in their application inventory and which apps used each version, so that they could, you might go and then point Nessus at those 5 apps to determine exploitability and wrap up your triage. But if you took an application or a project from out of management in the hub, you would no longer see that alert.
Got it. There was Stefan asked a question, and I think he said he probably missed this, but does Black Duck scan live containers, or does it scan images in a registry, say as part of a CI/CD pipeline, or both? What's the model?
I'll turn this one over to you, Kayla.
Yeah, absolutely. So we typically come in earlier on in the process. So we scan the Docker images, as well as if you are building those images through a CI tool such as Jenkins or something like that, we'll plug in there and actually scan the source before you're building it into the image.
Got it. There was also Max asked a question kind of in that same vein. He said, let's say Black Duck updated on a library that is defined in one of my Docker files. For example, my Docker file is the library XYZ 2.0.1 defined. If Black Duck fixes this version vulnerability, will it still be in the Docker file, or is he missing something here? If we remediate it, how does it change the actual Docker file, I think is the question.
Yeah, so that's a good question. So we're not necessarily looking at the Docker files at all to do the analysis and come up with the open source you're using. And then in terms of the remediation, we're not necessarily doing any remediation for you. It would require you to do the remediation on your end. And then typically you would rescan that application in, and you would no longer see that vulnerability impacting you any longer if you upgraded the version or applied a patch or something like that.
Got it. So the remediation is typically on the hands of the development team and the software team. This is about identifying, discovering, seeing what's changed on what's already in production, and working the stuff into your process. It makes a lot of sense.
That's right.
The last question came in from Daridi. He said, what kind of new vulnerabilities do you try to find? So you'd mentioned earlier, Mike, you guys try to find new vulnerabilities. What techniques are you using to find them? Can you just talk a little bit about, what percentage of your vulnerabilities are you finding that are actually you guys are discovering them versus you're mostly consolidating things that are being discovered and making sure people know about them?
Yeah. So I apologize if that wasn't clear. So we are not doing we are not building an abstract syntax tree. We're not attempting to find vulnerabilities in the code, in either the custom code that you're writing or in the open source components that you're using directly. And we're taking a much, actually, frankly, a much faster approach to it that fits in better with the whole CI/CD world. We're identifying the open source. We produce this laundry list, this bill of materials, and then we're mapping information from our knowledge base about that. So just to be clear, we're not trying to identify new vulnerabilities, previously undisclosed vulnerabilities in open source. We're merely identifying the open source that you're using down to the version level, and then mapping from our knowledge base information about vulnerabilities that have been disclosed either through the National Vulnerability Database or some of the couple of hundred other sources that we monitor.
And guys, if you're thinking about this, I think we covered this at the beginning of the day, but just to kind of reiterate it, what's happening is, there's best practices for securing your deployment, your infrastructure, the stuff that Rancher talked about. A lot of what New Vectors focuses on zero-day exploits, the things that aren't known vulnerabilities, the attack that's done because someone compromised a credential. They got to information somehow and were able to then all of a sudden try to do abnormal behavior. I mean that's what's what New Vector is really addressing. What Black Duck is addressing is the fact that it's you have these vulnerabilities out there very often that you don't necessarily know about, and they change constantly. The vulnerability list is coming in and being updated on the fly, and it's very hard to necessarily even know what all is in production and what vulnerability you're already exposed to. So I think of it that way if you're thinking of it. Secure the pipe, protect yourself for those 0-day unknown big mistakes. Somebody's doing something they're not supposed to be doing. You can't really just have one of these two things. You really do need to be securing how you develop code and how you run your application if you want to prevent yourself from having a really, really bad day where somebody gets access and encrypts your database or runs off with a half a season of Game of Thrones. So that's I think the broader concept should be something like that. Is that fair, Mike?
Yeah, that is. I mean, one of our customers put it this way, in his words. The worry with him about open source vulnerabilities or vulnerabilities in open source, and especially those with their publicly available exploit, is that it really lowers the bar for an attacker. And in his words, if the NSA wants to get into his bank, they're going to get in, and there's really not a heck of a lot he can do about it. And he's probably not going to lose his job over it. What he's going to lose his job over is a 16-year-old kid from New Jersey using a publicly available exploit on a publicly disclosed vulnerability that he's using, and he didn't bother to patch for it. And if you look back at these WannaCry things, this is, it wasn't open source, but it was unpatched systems. Microsoft had issued patches two or 3 months prior to that, the attacks on the NHS. And it was, these are just, they're not necessarily targeted attacks. They're more likely to be non-targeted attacks where I take an exploit and just point it at 1,000 IP addresses and see who comes back positive. And then, take my time and figure out who's worthwhile to probe further on.
Yeah, and that's a lot of what the new Vector guys are trying to address. Awesome. Kayla, you want to wrap up, or are you almost finished with your demo?
Yeah, I think there's one more quick feature I'll just touch on and allow you guys to see is the policy management feature in the hub. So it's a nice way to set policies around kind of the components, the open source components that you want to allow within your organization. So in a lot of cases, people will have this hooked up to a CI tool or something like that, and it allows them to set these policy rules, maybe specifically around, severities of vulnerabilities. And what this allows you to do is, let's say you want to set a policy in here that says, any component with 3 or higher high severity vulnerabilities, I want to flag it in the hub, and that way, as soon as I come in, I can be notified of what's kind of falling short of the policies that I've set, and put my immediate attention to that component.
Very cool. How do people integrate that into their CI flow? Like if you're using Jenkins, how do you integrate that?
Yeah, absolutely. So as soon as that Jenkins build is kicked off, as a post-build action, you would typically run the black duck scan. So as soon as that build is complete and the scan is kicked off, we would go through and find the open source components and then compare them against the policies that you have set within the hub, and then we'll report back to you in that build if the scan failed or is marked unstable because of policy violations.
Awesome. All right. Well, thank you so much, Kayla, for all the great the demo, Mike, for all the wonderful information, and for sharing everything here, and for kind of walking us through how people can get their hands on it. That was all great. I really appreciate it. Lots of good questions too from everyone in the audience. Okay, so hopefully everyone can see my screen. We're going to wrap up with just a couple things we always do. Just quick update on the latest release from Rancher. Will Chan, our head of engineering, is here on the call. I just asked him to join and chat real quickly about a 1.6. Will, you want to just touch that quickly?
Yeah. Can you hear me?
I can hear you just fine.
Perfect. Okay. So I think from the last meetup, we didn't really talk about 1.6 much. So I compiled a list of what I thought were the bigger ticket feature enhancements we've done in the 1.6 series. But if you want to get more information, you can of course go to our GitHub release page or our forums announcement, and it'll give you a lot more details than what was released in the last couple of months. So 1.6, here are some of the key things that we have done. Number one, we have made EBS, our storage volume drivers, it's GA now, so you can actually use it. The other feature that we added is our catalog support. So if you ever use our catalog, it was always global scale in terms of adding a new catalog into Rancher itself. We do now support being able to add a catalog per environment, so each environment has its own set of apps that you can deploy from. We did update, compose, and actually our CLI.
Well, new catalogs per environment, is that in the UI or just in the API right now? I know
this is actually, I believe it's in the UI. You should be able to get UI and add it there.
Okay, great. Yeah,
and this is again, I compiled this from 1.6.0 to 1.6.8. 1.6.8 is our 1.6.7. 1.6.7 is our latest stable. although we just shipped 168 yesterday, so it may include a little bit of those, and it really applies to the last two. Okay, now moving forward, for Compose, we have added additional fields. I didn't really want to go through it, but we have updated with a few new fields that we didn't support before. Same with CLI as well. So I think if you go to the release notes, they will tell you a bit more about that. With 168 that we just released yesterday, we started supporting, and I called it out here because even though it's not that big of a deal, if you ever wanted to change LDAP, the way you had to do it before, you actually had to disable it somehow. You had to stop auth, which is really bad, and so that required a bit of work on our end to make that seamless without actually disabling authentication while you do update anything with LDAP there. And then the last two things in terms of features, especially with 168, is support for RHEL 7.4 and Kubernetes 1.7.2. So you should see those latest updates. One more thing I want to call out is our IPsec overlay networking. It has gotten a lot better since 1.5, but 1.6 we did make a few more changes there. So hopefully the IPsec overlay network has gotten a lot more stable. I haven't seen too many issues with there, but 1.6 definitely has a few more fixes to making sure your IPsec overlay networking is a lot more stable than before. And then if you look at the release notes, I think we've added a few enhancements there. It's gotten a bit more verbose, but the two things I wanted to call out was the fact that we actually include instructions how to roll back to a previous release in case you hit issues with it. And the other thing is in the release notes, given that Rancher is built with multiple with microservices, I wanted to call each individual fix per each microservice. So you should see that in release notes as well. If there are fixes for example, the network container or the load balancer or the IPsec container, we'll call them out specifically. So you could see what's there and decide whether you want to upgrade or not when you upgrade your Rancher. Okay, so that's it from my side, Shannon.
Awesome, thanks, Will. If there's any questions for Will or any of these topics, feel free to fire them in. There was one, it looks like, Will, this is kind of a good question for you. Julian just asked, maybe kind of if there's time at the end, can we discuss differences between Rancher CLI and Rancher Compose? As a newcomer, I'm somewhat confused which to use. Do you want to just maybe talk about that?
Yeah, I can talk about that. So CLI is, so when I talk about Rancher UX, it really comes in 4 components. The entire UX is number one, the UI, which is built on top of our API, right? So a CLI is basically the command line version of our UI. So what you can do in the UI, I'm not sure it has the full set of features, but certainly you can do, so for example, in the UI, if you want to view the containers you have, list the containers, list the services, list the stacks, add a host, those things you can do from an API, but you can also use a command line tool to do the exact same thing. Compose is really your file that you use to describe the application you're going to use, that you're going to deploy on Rancher. So think about your Compose.yaml file, or if you use Kubernetes, it would be a Kubernetes YAML file. This really just describes the application that's comprised of containers that you want to deploy on Rancher. So that's the difference between the two. So UI, API, CLI, you use that to control Rancher in general, and Compose itself, whether it's Kubernetes or Compose, Docker Compose, are used to describe the application you want to deploy on Rancher.
Awesome, thanks, Will. There were a couple other quick questions as people got talking. One was from Jerome. He said, in the latest version of Rancher, can we use Calico as CNI? Is there a doc I can use?
We are working on that. Yes, the answer is you should be able to, but there are a few things. For example, we use our metadata service requires link local IPs. I'm not sure whether Calico supports it. It may. I just don't know on the top of my head. So there's a few things there that we would have to play around with to get it to work under Rancher, simply because of the way we use certain networks like link local IPs. So I do have an engineer that has worked on Calico. I just haven't made that available. So there are actually 3 network options that we will have. I'm not sure all of them are ready yet. IPsec definitely is there. VXLAN is there as well. And the last one is with no overlay. I think we call that host, subnet, or flat networking, where you would let us know how to assign the IP to it. You will let us know what IP you want to assign to the container. We'll simply do the IP assignment, but you would have to deal with the routing yourself with your physical switches, or even Amazon allows you to do it. The next thing we are looking to is to add Calico into our product. We have a couple somewhat working, but I just haven't released it as part of the catalog. I would expect that in probably a month or two. We just have to do some testing to make sure it does work. But for you to do it yourself, it's a bit harder. Just because you may not know how we have what requirements we may have on the networking itself.
Yeah, Jerome, if you want to shoot an email to Shannon@rancher.com, and I can sort of kick off a little discussion on that. The next question was, last question, Boris just said, any update or plans to add Bitbucket support? You know, we've got Bitbucket supported for auth and maybe code pulling.
It's always been something that I'm aware of. I haven't added specific to it yet. However, our authentication framework is a microservice now. In the old days, it was built as part of the Java Rancher component. It's its own microservice now. So, if possible, if you want to help contribute, you're welcome to do so. We just haven't done it. I think the latest one we have added support is SAML, and so we haven't done it ourselves. It's actually something we want to do, but it's not in a particular roadmap that I can give you.
Yeah, it's asked for occasionally, not all that often, Boris, too. So if it is something, we'd love to see it, the kind of thing that if someone in the community wants it and can help, we're happy to give you guidance on how to write that and derive it. It just hasn't been, it kind of hasn't floated up to the top.
I believe it uses OAuth, so it could follow very similar to how we've implemented GitHub. I would assume that you can just leverage a lot of the code that we did to add GitHub integration.
Okay, Will, thanks for answering all those questions. There was a question earlier, Max, that Max had asked Mike about Black Duck, sort of just saying, are there any blogs or posts that kind of explain how to integrate this into your CI pipeline, have it working with Jenkins? If you've got any posts like that, if you want to sort of maybe send them out to send it out as a question, I'll repost it to everybody on here as well.
Okay, great. I'll have to look it up.
Okay, great. All right, so thanks, Will. Last slide is someone's asking what's the next thing coming. So next month we're going to be doing a tech preview of Rancher 2.0. Lots of cool stuff, and the next meetup will actually be all about Rancher 2.0. So I won't get into too many spoilers for now, other than to say there's a lot of amazing new UI. There's a ton of new cool features. A lot of things people have been asking for some time are all part of this. The basic plan with 2.0 is to roll out a tech preview, kind of alpha phase in late September, and work with the community, keep improving it through the fall, and hopefully GA it as we get towards the end of the year. In the meantime, all new features are going into that. 1.6 is your stable, what you need to be running if you're running anything in production. For the next few months, we'll be continuing to make patches, improvements, as Will just talked about to that. So that's the long-term support type of component that you want to use for anybody that's running stable. So lots of cool stuff coming on Rancher 2.0. For those of you who haven't tried Rancher yet, why go to rancher.com, go to our Getting Started page, go to GitHub. It's open source, 100%. It's all free. Use it, try it, get involved, pull down Rancher OS. If you want to try it and you don't have a server, go to try.rancher.com and you can get a free environment that you can use as long as you want. Play with it, use it, spin it up. People are running thousands of these things out there with lots of hosts to kind of tinker with. It's not production grade. We don't claim it is, but it's pretty damn good. We run free training classes every month on both Kubernetes and Rancher and how they work together. You can join those. Just go to rancher.com/training. And with that, I want to thank all of our speakers today. Faye, Mike, Kyla, Bill, Will, everyone who joined. I really appreciate your time. For those 100+ of you who are still on this call after 2 hours, you are troopers and awesome. Thanks for being part of our community. We love you all. And if you need anything, have suggestions, would like to propose topics, want to speak at one of these and show off the cool stuff you're doing at your company, shoot me an email, shannon@rancher.com, or you can hit me on Twitter at smw355, and we will see you next month to talk about Rancher 2.0. Thanks, everyone. Have a wonderful day.